In example 3, there are 5 systems that we are going to solve using Gauss-Jordan elimination. Make sure you look at the directions here. It says if there is not a unique solution, either state no solution or infinitely many solutions. And in the case of infinitely many solutions, parameterize the solutions and give one particular solution. So keep that in mind if you do not get a unique solution. All right, in example A, here is our system of equations. We have 3 equations and 3 variables. Okay, so we've got 3x plus 5y minus z is equal to -7, x plus y plus z is equal to -1, and 2x plus 11z is equal to 7. Okay, so we are going to solve this system using Gauss-Jordan elimination. And remember what that means. We're trying to figure out the x, the y, and the z. So if you plug those values into all 3 equations, it makes all 3 equations true. Okay. All right. First thing we have to do is construct our first matrix. Okay. So we're going to translate this system, okay, into matrix form. So look at the first equation there. There's a 3 in front of x, a 5 in front of y, a -1 in front of z. Draw your vertical line. There's a -7 on the other side. Okay. Second equation, 1 in front of x, 1 in front of y, 1 in front of z, -1 on the other side of the equal sign. Okay. And then last equation, there is a 2 in front of x. We are missing y, so use a 0 there. You have to. And then 11 in front of z, 7 on the other side of the equal sign. Okay, so that's your first matrix. Okay, all right, so now we're going to start using our 3 row operations. Okay, so again, let me put up here before we keep going. Okay, what is the goal? Okay, this is a system, a larger system now. We've got 3 equations and 3 variables. Okay, your goal is to have the identity matrix on the left side of the vertical bar. Okay, so that means 1s on the main diagonal, 0s above and below those, okay? And then you should get numbers on the right-hand side, okay? That is your goal, okay? We are going to start, remember, systematically, column by column. We are going to start in the first column, okay? And we want to secure a 1 on the main diagonal, okay? So remember, these are the main diagonal elements, okay? So in the first column, here's your principal diagonal element. You want to change that 3 to a 1. Okay, so remember, the best way to achieve your 1s, okay, either switch 2 rows if you can, or if not, you're going to have to multiply or divide the entire row by a non-zero number. Okay, well, here, all we need to do is switch rows 1 and 2, okay, because there is a 1 right here. If we switch the rows, that'll put a 1 right here. Okay, so again, remember, I'm going to want you to indicate how you go from one matrix to the next. Okay, so to get the next matrix, we are going to do row 1 switched with row 2. Okay, so make sure you write out this little shorthand notation. Okay, all right. So if we make this switch, okay, remember, nothing is going to happen to row 3. Okay, so I'm just going to go ahead and write that down. Okay, and now I'm going to switch the 2 rows. So the first row is going to become the second row. Okay, remember, the entire row switches, including the -7. Okay, and then what was the second row will now become the first row. Okay, and now we've got a 1 on in this spot. Okay, all right, so now you keep working in the first column. Okay, so we're working here, so I'm just indicating which column I'm working on. Okay, so you've got your 1 on the principal diagonal. Now you've got to 0 out the rest of the column. Okay, so now I'm going to change this 3 to a 0. Okay, so remember, to get your zeros, you want to use the third row operation. Okay, so remember what that means. Okay, if you're trying to change a row, you're going to add to it a multiple of a different row. Okay, so the key to understanding this, okay, is if you're working in the first column, okay, once you've secured your 1 and you're trying to 0 everything out, okay, since you're working in the first column, the first row is what's going to get multiplied by stuff. You're using that 1 that you've just put there to zero out the rest of the column, okay? So if we want this to be a 0, what is going to cancel out a 3? Well, a -3. So what we're going to do, if we multiplied this row, the first row, by -3, that would put a -3 right here. And then when you add it back to +3, you're going to get your 0. Okay, so for the next matrix, to get the next matrix, your row operation is going to be -3 times the first row, add it back to the second row. That's going to replace the second row. Okay, all right, so first thing I'm going to do so I don't get confused, okay, I'm only changing row 2. So I'm going to rewrite row 1 because it's not changing, and I'm going to rewrite row 3 because it's not changing. Okay, now I'm going to go out to the side and do my work, okay, and then I will replace row 2. Okay, so do what the operation says. I'm going to go out to the side. I'm going to do -3 times row 1. So every number in row 1 has to get multiplied by -3. Be careful with your signs. You're going to get -3, -3, -3. Negative times negative will give you +3 as the last element, okay? Then you've got to add row 2 back to it, okay? So go back to the previous matrix, write down row 2, and then you're going to add these numbers, okay? So -3 plus 3 is 0. -3 plus 5 is +2. -3 plus -1 is -4. You've got to be careful with your signs. 3 plus a -7 is 3 minus 7. That's -4. Okay, that is your new second row. Okay, so here you go. All right. Okay. All right. So we got our 0 here. So we've got to finish off the first column. Okay, we are still in the first column. I need to 0 this guy out now. Okay, so let's talk about it. Okay, remember, you want to get rid of a +2. What is going to cancel a +2? A -2. Since you are in the first column, that means the first row is getting multiplied by stuff. Okay, so we're going to multiply the first row by -2. -2 times 1 will put a -2 here. Okay, when you add it back to the third row, okay, -2 plus +2 will give you the 0. Okay, so for your next matrix, okay, how are you going to get there? Well, we're going to do -2 times the first row, add it back to the third row. That's going to become the new third row. Okay, all right, so let's go do it. Okay, so when I write my new matrix, okay, remember I'm only changing row 3. So I'm going to leave row 1 alone. I'm going to leave row 2 alone. And then I'm going to go out to the side and do the work to get the new third row. Okay, so let's do what the row operation says to do. I'm going to do -2 times the first row. Okay, so you're going to have to send -2 times through, you have to multiply the entire first row, every number in there by -2. So you're going to get -2, -2, -2, negative times negative is going to be positive. Okay, then we are going to add row 3 back to this. Okay, so go back to the previous matrix, look at row 3. We've got 2, 0, 11, and 7. We've got to add here. Okay, so -2 plus 2 is 0, or -2 plus 0 is -2. -2 plus 11 is +9, and 2 plus 7 is 9. Okay, so there is your new third row. Okay, and now we have finished off the first column. You've got a 1 on the principal diagonal. The rest of the column is zeroed out. Okay, time to move on to column number 2. Okay, as soon as you start a new column, you need to secure a 1 on the principal diagonal. Okay, here's your principal diagonal element. Okay, so you need to change this 2 to a 1. Okay, remember, when you are getting 1s, the easiest way to do that is to do one of the first 2 row operations, either switch rows or multiply or divide the row by a non-zero number. Okay, you don't want to switch rows here, okay, because that would undo your work in the first column. Okay, But if you notice, everything in the second uh, row is divisible by 2, which is nice because we won't get any fractions, okay? The easiest way to get a 1 right here is to do 2 divided by 2. Okay, so we're going to take the entire second row and divide by 2. And like I said, we're going to be lucky because we're not going to get any fractions, okay? So let's do that. So let's go ahead and write down our next matrix. Okay, so this is going to be matrix number 5, I think. Oops, let me move it over. I'm on a new page here. All right, so let's see here. To get our next one, we said we were going to take row 2 and divide every element by 2, and that's going to become our new row 2. Okay, so remember, only row 2 is changing here. Okay, so when we write down our matrix before we change row 2, let's go ahead and keep row 1 the same, as well as row 3. Okay, no changes to those. Okay, and then remember, we need to go back to our second row and divide everything by 2. So it's going to be 0, 1, -2, -2. Okay, so I'm just write that in. Okay, so 0, 1, -2, -2. Okay, all right. So that's our updated matrix there. Okay, all right. So we are still going to work in the second column. We've got the 1 on the principal diagonal. So now we need to zero out the rest of the column. Okay, so you need to zero out the 1 and the -2. It really doesn't matter which one you do first. Okay, I typically go from top to bottom out of practice, out of habit, but really it doesn't matter which one you do first. Okay, all right, so let's start here. Okay, we need to change this element to a 0. Okay, all right, so again, if you're trying to zero out, you want to use the third row operation. Okay, so you're going to replace the first row, you're going to add to it a multiple of another row. Okay, so since we are working in the second column, that means we're going to multiply the second row by something. Okay, you have a 1 here, you want to zero it out. What is going to cancel a positive 1? Well, a -1. Okay, so if we take the second row and multiply by -1, okay, that'll be -1 times +1, that'll put a -1 here, okay? Then if you add it back to +1, you will get your 0, okay? So for your next matrix, okay, our row operation is going to be, we're going to do -1 times the second row, add to it row 1, add it back to row 1. That's going to become the new first row, okay? All right, so let's do that, okay? All right, so here we are going to change only row 1, okay? So in my next matrix, I'm going to go ahead and leave row 2 alone, and I'm going to leave row 3 alone, okay? And then I'll go out to the side and do the work for the new row 1, okay? All right, so let's do exactly what this row operation says to do, okay? I need to go to row 2 and multiply everything by -1, okay? So here we go. If we are multiplying everything by -1, it's just going to change the sign of everything. So we're going to get 0, -1, +2, +2, okay? And then we're going to add it back to row 1. So go back to the previous matrix, write down your row 1, okay? And now we're going to add these numbers, okay? And that will be the new row 1, okay? So if we add 0 plus 1, -1 plus 1 is 0, 2 plus 1 is 3, 2 plus a -1 is 2 minus 1. That is going to be +1, okay? So there is your new first row, okay? All right, still working in the the second column, okay? So now we need to zero this guy out, okay? All right, so we have a -2. We want it to be a 0. We're going to again use the third row operation to get our 0, okay? So to change row 3, we're going to have to add to row 3 a multiple of a different row, okay? So if we want to cancel a -2, okay, we need +2 to cancel the -2, okay? Again, since we are in the second column, we need to multiply the second row by something, okay? So we're going to multiply by +2 to cancel the -2, okay? If we did this, 2 times 1 will put a 2 here. You add it back to -2, you will get your 0, okay? So for the next matrix, matrix 7, this is a lengthy process, okay, especially as you go up in size, okay? Your next row operation is going to be 2 times the second row, add it back to the third row. That will be the new third row, okay? All right, so let's do this, okay? In writing down my new matrix, okay, I'm making a change to row 3, so I'm going to leave row 1 alone. I'm going to leave row 2 alone. Okay, and then I'm going to go out to the side and do this work. Okay, so do exactly what this row operation says. I'm going to do 2 times row 2. Okay, so let's see, we're going to run 2 through these numbers. Okay, so let's do that. So we're going to get 0, 2, -4, -4 if you do the multiplication. Okay, now you're going to add back to it row 3. So go back to the previous matrix. Okay, look at row 3. Let's write this down. Okay, add. Okay, we're going to get 0, 2 plus or 2 minus or 2 plus a -2 is 2 minus 2. That's going to give you 0. Okay, -4 plus 9 is 5. -4 plus 9 is 5. Okay, there's your new third row. Okay, and we are done with the second column. Okay, you have a 1 on the principal diagonal. It's zeroed out above and below. Time to move on to column 3. Okay, first order of business in column 3, secure the 1 on the main diagonal. Okay, that's right here. Okay, the 5 needs to change to a 1. Okay, switching rows does not help here because it will undo what you did in the first 2 columns. Okay, so you're going to have to multiply or divide the entire row by a non-zero number. Okay, the easiest way to get the 1 here is going to be 5 divided by 5. Okay, that will get you the 1. So we're going to take the entire third row and divide by 5. Okay, so our 8th matrix, okay, we're going to get by taking row 3, dividing by 5, that will become the new row 3. Okay, all right, so let's write that down. Okay, row 1 will stay the same, row 2 will stay the same. Okay, take everything in row 3 and divide by 5. 0 divided by 5 is 0. 0 divided by 5 is 0. 5 divided by 5 is 1. 5 divided by 5 is 1. Okay, so there's your updated matrix. You've got a 1 on the main diagonal. Okay, so we are still working in the third column. Okay, we're almost there. Okay, we need to zero out the rest of this column. Okay, again, out of habit, I go from top to bottom. So I'm going to start with this 3 right here. Okay, I'm going to change that to a 0. Okay, got to use your third row operation. Okay, if I want to change row 1, I'm going to have to add to it a multiple of a different row. Okay, again, since we're in column 3, we need to multiply row 3 by something. Okay, since we have a 3 we're trying to cancel out, a -3 would cancel it out. All right, so if we multiply row 3 by -3, if we do -3 times +1, that will put a -3 right here. Add it back to the first row, -3 plus 3 will give you the 0. Okay, so to go to the next matrix, we are going to do -3 times row 3, add it back to the first row. That will become the new first row. Okay, all right, so let's do this. Okay, when you write down your next matrix, only row 1 changes. So I'm going to leave row 2 alone. I'm going to leave row 3 alone. I'm going to go out to the side and I'm going to do my work. Okay, I'm going to do -3 times row 3. That's going to give me 0, 0, -3, -3. Now I need to add it back to row 1. So go to the previous matrix and write down row 1 and add. Okay, we're going to get 1, 0, 0, -2. Okay, so that's your new first row. All right, we have one more element to change. Okay, lastly, in the third column, we need to change this -2 to a 0. Okay, again, third row operation is going to be the way to go. Okay, so we are going to, oops, I don't know where that line came from. Get rid of that. Okay, so what we're going to have to do is we're going to have to zero this out. Okay, use the third row operation. So we're going to, if we want to change row 2, we're going to have to take row 2 and add to it a multiple of another row. Okay, since you're in column 3, you're going to want to multiply row 3 by something. Okay, since we're trying to cancel a -2, we're going to multiply by +2. Okay, so if we do 2 times 1, that will put a +2 here. Okay, add it back to -2, you'll get your 0. So for our final matrix, okay, our row operation is going to be +2 times row 3, add that back to the second row, and that will change the second row. Okay, all right, so this last matrix, we are only changing row 2. Okay, so we're going to leave row 1 alone. We're going to leave row 3 alone. Okay, I'm going to go out to the side and do my work here. Okay, I need to do 2 times row 3. So write down row 3. Okay, multiply everything by 2. So we're going to get 0, 0, 2, 2. Add row 2 back to it. Okay, so go back to the previous matrix, write down row 2. Okay, and now add. Okay, we're going to get 0 plus 0, 0 plus 1, 2 plus -2, 2 plus -2. Okay, here is your new second row. Okay, and we're done. Okay, we have achieved the identity matrix on the left side. We've met our goal. Okay, since we were able to achieve the goal, okay, that means there is a unique solution. We can identify the X, the Y, and the Z. Okay, so all you need to do, okay, is translate this last matrix back into a system of equations. Okay, so remember these first numbers, or this first column, those are the numbers in front of X. The second column, those are numbers in front of Y. The third column, those are the numbers in front of Z. Okay, so if you translate it back, okay, this first row is going to be 1 times X plus 0 times Y plus 0 times Z. Okay, well, okay, if you wrote that out, is going to be equal to -2. Okay, so these guys cancel. You get that X is -2. Okay, so if you translate this first row back into an equation, okay, you get that X is -2. Okay, and you can do that for the rest of these. Okay, like if you look at this second row, okay, it's going to be 0 times X plus 1 times Y plus 0 times Z is equal to 0. Okay, this goes away, you're left with Y equals 0. Okay, it's possible for one of the variables to be 0, so don't be alarmed by that. Okay, so if you translate that second equation back, okay, you should get that Y equals 0. Okay, and then lastly, we can do it to the third equation here. Okay, the third equation is going to be 0 times X plus 0 times Y plus 1 times Z is equal to 1. Cancel, cancel, Z is equal to 1. Okay, so there is your unique solution. Okay, all right, so let me write this down. Okay, and you don't have to translate it back into equations. Okay, once you get the identity matrix here, okay, this is your X, this is your Y, this is your Z. Okay, so there you go. All right, so I'm going to go back to the original problem on the other page, and I'm going to write down my answer for this system. Okay, so I'll put up here that the solution is, okay, let's talk about how we can write this down. Okay, X is -2, Y is 0, Z has to be 1. Okay, so you can either spell it out like this, or you can write it as an ordered triple. Okay, X has to go first, then Y, then Z. It must be in that order. Okay, so there's your solution. Okay, and remember, you can always check yourself. Okay, if you plug in these variable assignments, okay, if you plug in these variable assignments, take each of these X, Y's, and Z's and plug them into all 3 equations, you should get a true statement for each one of those. Okay, and I'll leave you to check that if you wish. Okay, long process. Okay, you just have to be you have to do it systematically, going column to column, securing the one on the main diagonal first, then zeroing out the rest of the column, okay? And you've got to be very vigilant with your arithmetic. Let's try another one.